Okay. We're in lesson 3.4, where we're going to be solving inequalities using addition and subtraction. This lesson will be very similar to topics we worked on in chapter 2. The only difference is instead of it being an equal sign that we're solving with, we're going to be using an inequality. Now, inequalities are represented 4 different ways, and it can be shown on the chart here. If you look here, this inequality is called x is less than or equal to 3. So anytime you see the alligator opening up towards the right side number and it has a line underneath it, we can say that that is less than or equal to. If we go to the next one, I have z is greater than or equal to -4. So anytime the alligators are opening up towards the left side value, then, and it also has the line underneath it, we can say that it's greater than or equal to. The next one is n is less than 4. Again, anytime that the alligator is opening up to the right side value but does not have a line underneath it, it's just written as less than. And then the last one is x is greater than -5. Alligator's opening up to the left side value and does not have a line underneath it, so it's denoted as just greater than. From this assignment, you're going to be asked to graph these inequalities. So let's take a look at the first one. So I have x is less than or equal to 3. So here's how you graph that. First, you're going to find 3 on your number line. Okay? Now, here's something that's very important. If there is a line underneath the inequality, like less than or equal to, or greater than or equal to, it is graphed with a closed circle. So I'm going to fill in this circle. Okay? If it does not, then it would have what is called a open circle. So just to be clear, these ones are closed circles, and then these two would be considered open. Now, the shading portion. The shading portion comes from determining which values make x a true statement. So, does 2 make x a true statement? Yes, it does. Does 4 make it a true statement? No, it does not. So, any value on the left-hand side of 3 will make this a true statement. And so I'm just going to shade it in and look like I have an arrow here. Okay? If you are confused with that, here's one way to determine that. If your variable is on the left-hand side of our inequality like it is in these 4 examples, take a look at the inequality itself. See how it has looks like an arrow and it's pointing towards the left-hand side? So anytime that our variable is on the left-hand side of our inequality, and we can look at our inequality as an arrow, which way is it pointing, that's where our shading is going to be represented. So if you take a look at the second one, z is greater than or equal to -4, We go to -4. We know that it's an equal to, which has the line underneath it, so it's going to be a closed circle. And the shading portion comes from, if you notice, this arrow is pointing towards the right. So it's telling us that we need to shade it to the right. Okay? If we have n is less than 4, now, because there's no line underneath it, it is just an open circle. We do not shade it in. And again, our arrow is pointing to the left. And then the last one, x is greater than -5. I go to -5, I know it is an open circle, and it is an arrow pointing towards the right. Okay? So you're probably thinking, how are we going to solve inequalities? So the goal of solving inequalities is still the same thing as solving equations. I still want to get my variable by itself on one side of the equal sign. So I have m plus 5 is greater than or equal to 10. I would solve this inequality just like I would solve m plus 5 equals 10. So if you use those same rules that we were using with equations, we're still going to be okay when we're solving inequalities. So we still want to get that variable by itself on one side of the equal sign. So I'm going to subtract 5 from both sides, which then cancels this out, which leaves me with m on the left-hand side. I bring down the greater than or equal to, and 10 minus 5 is just 5. So now I need to graph this inequality. So I need to find 5. Now we have to think, okay, is it a opened or closed circle? Because it has the line underneath it, I know that it is a closed circle. And I look at my answer. My variable's on the left-hand side, so I can use my arrow that's going to point and show me where my shading's going to go. And it's telling me that it's pointing towards the right-hand side. Okay, let's look at this story problem. It says you are competing in a triathlon, a sport competition with 3 events. Last year, you finished the triathlon in 85 minutes. The table shows your times for this year's first 2 events. What possible times can you post in the running event and still beat last year's finishing time? Okay. They don't tell us the running event, so let's just say that this is X minutes. So they want you to write a verbal model. Let's just go right into writing the inequality of this situation. Okay, so I know that I have 17 minutes for swimming plus 45 minutes for biking plus X, and I know that last year's time was 85. Okay, what they're asking is, what are the possible times you can post in the running event and still beat last year's time? So what that means is that's telling us that it's an inequality. And the inequality here is going to be less than, because you want to be faster than 85 minutes. But you don't want to be less than or equal to, because if you were the same time, you wouldn't have beat last year's time. So looking at this inequality, you're still going to treat it just like you would if it was an equation. You're going to solve for the like terms. So I got 17 here. I got 45 here. Now what's 17 plus 45? That is a, so we got what, 2 and 62 is less than 85. So now, no, I'm sorry, that's wrong. Whoops. I'm going to try that again. My bad. What you have to do is first add 17 plus 45, which gives you 62. 62 plus x is less than 85. Sorry about that. I wrote it wrong. Now, I can subtract 62 from both sides, which leaves me with x, and 85 minus 62 equals 23. And it is less than. So my time can be less than 23. So if I were to graph this inequality, I put 23 in the center, have this as a open circle, and my shading is going to go to the left. Okay? Now we're just going to solve and graph our solutions. These are several problems you're going to have in your homework problems. Here I'm going to subtract 4 to both sides, cancel this out. X is greater than 1. So if I graph this equation, or inequality, I'm sorry, I'm going to have 1, open circle, and the shading is going to the left. Because my inequality, or my variable is on the left-hand side of the inequality, my arrow is telling me where I need to shade. Here, again, I'm going to subtract 1 to both sides, cancel it out, so I'm left with f is greater than or equal to -9. If I'm going to graph this, I'm going to go -9 is going to be a closed circle because I got the line underneath it, and it's going to be shaded to the right. Last thing here is they're going to give you a graph, and they're going to ask you to write an inequality that reflects this graph on the number line. So if I look here, I have an open circle at 1, and it's shaded to the left. So what I would do is write a variable, which I'm going to give as x, and I'm going to write 1. Now, looking at it, it's moving towards the left. So remember, since our inequality is on the left-hand side, we can just use the arrow. And so it's going to be x is less than 1. There is no line underneath it because of the open circle. And that is being able to add or subtract inequalities. Hope this helps. Until next time.